First of all, very good morning to all. And I am Priti Choudhary, Assistant Professor, Department of IT, and from AKGEC. So today I will discuss the second lecture of data analytics, that is the SVM. SVM is a support vector machine. This is used in a machine learning also and analyze the data analytics and find out the nature of data tools. So SVM is a tool, tool where it is used for find out the data is linear form or non-linear form. So that data is this SVM is used for the classification our data. Let's suppose we have the two types of data, yes or no. So we can easily separate that data by using SVM. Okay, so in this lecture, we will discuss about the SVM, how it is SVM work on linear data and non-linear data. Now comes to the first point, that is the SVM and kernel method. It is the main topic. So firstly, I tell you what is SVM. SVM support vector machine. SVM is a powerful supervised machine learning algorithm. Machine learning is a where we use the past data and find out the future data. It's called the machine learning techniques, and machine learning techniques also classified two types, supervised and unsupervised techniques. So SVM is the powerful part of the supervised machine learning techniques. This is used for the classification mainly because here the separate our data in different class. Okay, so it is used for classification, but also some data also used in a regression form, outlier detection, where I use the SVM. In simple word, we can say that SVM try to create the boundary that separate the different class of our data. So that boundary is called the hyperplane of SVM. Suppose we want to classify student in a class A, class B. Okay, classify the student in different class. So some student in a class, some student pass and some student fail according to their scored marks. So we create the class of that student. Class A, pass student, for pass student, and class B for fail student. So SVM find the line and plane where we classified that two classes. Okay, now comes to the SVM are the different form other classification algorithm also used because of the way choose the decision boundary that maximize the distance from the nearest data points. So all the classes, the decision boundary created by SVM is called the maximum margin. Classifier a maximum margin hyperplane. According to this, here the data points. These points are the data points, or this is the data space where some is scattered the data points. Now these line separate this data class and this data class. So this separate line is called the hyperplane line. Okay, or the boundary, or also called a hyperplane line. Okay, this is the main line and main boundary. Main line and main boundary what mainly separated our classes in a data. There are some terms, many terms, important terms used in SVM. First one is the hyperplane. Hyperplane just a boundary, decision boundary that separate classes, data classes. Okay. Second one is the support vector. Support vector also the important terms which is used in SVM. Data point closes the boundary. Let's suppose we take the example here. So this is the nearest point of this boundary and this is the nearest. So these 2 points is the support vector. Okay, these points help to define the position of hyperplane. Now comes to the margin. What is the margin? Distance between the hyperplane and nearest data point. Let's suppose we take the example this portion is the margin. This is the part of margin plane. So these three terms used in SVM: hyperplane, support vector, and margin. So hyperplane is the decision boundary, just simple, that is separate our data classes. Second point is support vector. Support vector points the closest the boundary points, data points, and it is also define the position of hyperplane. And next point is margin. Margin the distance between hyperplane and nearest data points. Okay, so that for the linear SVM means where the data is used already in different classes. Just we create the a single line. It is called as linear SVM, means where the data is linear form. Okay, the decision boundary doesn't have to be a line. It also refer to the hyperplane, because you have find the decision boundary with any numbers of features, just 2 points. So here the two classes, and we create the simple hyperplane. So we can get the this data is classified into two forms, this one form and this in second form. But there the data is different, but also classified easily two forms. This is a circle way. Okay, this called the this form. Now types of SVM. There are the two types of SVM on used in different things. First one the simple SVM, and second one is kernel SVM. Simple SVM means it is basically used for linear regression and classification problems. Okay, and second one is the kernel SVM. Kernel SVM has more flexibility for non-linear data, because you can add more features to fit the data. You create the hyperplane instead the two-dimension data. Here we use we use only the two types of attributes, so we can easily classify it into two class or three class. But here data is non-linear, means data is totally in different scattered in whole database plane. So there's problem created how to classify that data. That time we need the kernel data is here. Okay, why we use the SVM in data analytics? Problem main point is here. So SVM is widely used because SVM work well with high dimension data, means 1D, 2D and 3D in all dimensional data. SVM is work easily. SVM separate the data in different form. Effective for small and medium data set, very less in large amount of data set. Why use the SVM in data analytics? SVM is widely used because it is work well with high dimensional, mean data is used 2D, 3D and other data. It can work well, and effective for small and medium data set, very effective. Good accuracy with handle complex relationship between attributes. And application of this SVM in data analytics: easily find out the spam email detection, image classification and customer segmentation and fraud detection. These are the application of SVM in DA. These are some images where, let's suppose here we take the example, here the data is not in separatable form, not a linear data, so we cannot create that directly a linear hyperplane. So here, according to this image, we cannot create that directly hyperplane. The boundary line means this problem is not solved by the linear SVM. So we need this data move to this form, 2D form. So here feature space include also, and now this green part is SVM, and this SVM is generate the two different classes here. Got it? Now comes to the linear versus non-linear problem. The linear data means where the data is totally linear and easily classified into 2 and 3 classes. But non-linear data, where the data is mixed, not classified proper in different ways. So there time we need the other type of SVM, that is called the kernel SVM. Or here we use part 1, here we use the linear SVM, or here we use the other types of SVM. Same problem is this is all the next example same. Here we use the linear separable, and linear separable use the linear SVM. Okay, and here we use the non-linear separable, so there I use the kernel SVM. So same thing is this. Here the linear kernel easily classified in different classes, but problem is this, not classified is proper. So sometimes data cannot be separated using straight line, state boundary. That time we use the kernel SVM. This kernel SVM solves this type of problem? The definition is kernel is a mathematical function that transform data into a higher dimension space so that it become linearly separable. This concept is called a kernel tricks. Why kernel is need in SVM and solve these problems? The main example is data arranged in a circle, so cannot create a straight line. So this time we need the kernel. Okay, kernel transform the data into higher dimension. According to this last image here, the data is not a linear form, data is different form. So this data by using kernel create the 2D form. Okay, and kernel transform data into a higher dimension, and SVM is separately. So now kernel SVM easily separate this data. Now tell you the types of kernel SVM, but kernel SVM in a SVM kernel is different types. So first one is linear kernel. Linear kernel use data is already linear form, linear separable. So these types commonly recommend the text classification because most of the types of classification problems are linearly separable. Yes or no? So there are the two classes, yes or no. So the text classification problem have a lot of features. Linear kernel function are the faster, and most of the other you have fewer parameters you optimize. So this is the simple function of linear kernel. So W T X plus V. This is the simple equation of linear f is the function. Here the W it means the weight vector, that is the X is the data point, and use in the B is the linear coefficient estimate the training data. Okay, now comes to the next kernel, that is the polynomial kernel. Polynomial kernel means when the relationship curve means your data 2 and 3 classes in your data use a circle way, a polynomial way. So that on data we required the polynomial kernel. The polynomial kernel is not a practice very often because it is the computationally efficient as other kernel. Its predicts are not accurate. The function for the polynomial is this. So here x or y, function x, y represent the polynomial decision boundary that will be separately data, or x or y is your main data, means attribute data. Now comes to the next kernel, that is the RBF. RBF means radial basis function. Radial basis function is the one of the powerful and commonly used kernel in SVM. Especially the this kernel is especially used on non-linear data set. This kernel function is used mostly and handle complex data set and create the flexibility for decision boundary. Here the equations for the RBF kernel x1, x2, these are the simple equations of RBFF. x1, x2 the dot product between the your more than two features. Okay. Next kernel is sigmoid. Sigmoid kernel, this kernel is also used in a NN types of technology, neural network technology, and neural in a SVM machine, but there are sigmoid function especially used on NN as compared to SVM, but there are occasionally specified we can use in special cases, and the function of sigmoid is this: 10h alpha star xt plus multiply y plus c. So alpha is the weight vector, c is the offset value of account, some misclassification of data that can be happen, or these activation function also work in a neural network NN. Let's suppose sigmoid function especially use the classification problem. Sigmoid function especially work this form 0 and 1. Here the class is here data is your data is belong to this portion, otherwise your data is belong to this portion. This is the 1 or 2. So he classified your data into two form. Now comes to the second point, SVM working steps. SVM working steps, especially here we create our data set and data classified into two form, training and testing. We take some data for training, data used for training purpose, and after apply the kernel types, choose the kernel type, then find out the support vector and create the optimal hyperplane and classify our data in different class. So this is the simple working step of SVM. Advantage of SVM: it gives the high accuracy, work well is complex data, and less overfitting, find out our models and the effective in high dimensions. And limitation of this flow is very large data set. So it is a very bad, poorly performance in very large data set. Kernel selection can be difficult in some situations. So this is the main limitation of SVM. Now comes to the real-time example where I use the SVM in DA. So in a data analytics, SVM can be classified as an email, find out the emails is spam or not spam. Kernel method help to the patterns are complex and non-linear data. Support vector machine is a supervised data is classified, and this is the simple way of separated. Now comes to the next point, that is the time series analysis. Time series analysis is mean the where there are the more definition of TS for make the simple. Time series is nothing but just a sequence of various data points occurred to the successive order in a given period of time. Objective of time series analysis: to understand the time series work, what factors are affecting the certain value different data point of a time. Time series analysis will be provide the consequence, insight and feature given in the, so here data set convert into time series and find out over the period of time, supporting the drives in predicting the future value of the time in time series variable. Assumption: there are the one and more assumption, that is stationary data may be data always be stationary, which means the origin of data does not affect the property of process under the statistical factors. Now, how to analyze the time series data? Quick steps here we use. First of all, collecting data. After collecting data, we clean it and preparing and visualize and check it data is respected to time versus the key features. Observing data is variety, it is a stationary data or not a stationary data. If data is stationary data, then you can easily find out the some points, trend, visuality and residual. These find out in your data and understand your data nature after applying the time series model. AR model, ARIMA model, ARMA models, these are the different of time series model, and easily find out the forecasting value and future value in a time. So significance of time series and its types. So time series analysis is the backbone of prediction and forecasting analysis. Sometimes specific of time-based problem statement, analyze the historical data and its patterns, easily find out by using time series. Also understanding and matching the current situations with the pattern and drive from the previous data or past data. Understanding the factors of influencing the certain variables, and time series can be prepared the numeric form, analyzing. So here they are the use different mainly forecasting. We can use this time series techniques in a forecasting, segmentation, classification, descriptive, and the intervention analysis. Now comes to the component of time series. When your data collect from different place and after cleaning and pre-processing, then you find out, apply visualization techniques on that data and check the trend, seasonality and cycle irregularity. These are the different components which is used in time series, and after these components checked in your data, then find out the which types of model apply on your data. Trend means where the no fixed interval. It means data is increasing order, or maybe it continuously increasing order, maybe continuously decreasing order. Let's suppose take the example of this by graph. So this is your data. It means data is move continuously up direction. So this is the trending is increasing form. Now comes to the next component, that is the seasonality. Seasonality means the fixed interval shift within a data set in continuously time means. That means the second example of seasonality, it means your data is in this form. So here this data is first cycle and first season, and also this is the seasonality. Now comes to the second one, cyclic. Cyclic also the seasonality, the part of fixed interval and certainly the movement of edit pattern. Irregularity means there are no situation, no trend find out, no cycle find out. मतलब एक just a fluctuation of your data. Given the types of fluctuation, just let's suppose your data is. So in this data, we cannot fact your data is trend data, seasonality data, and the cyclic data. If your data also check the stationary. If your data is stationary, then you can apply the time series techniques and change your data in different this form. So this is the component of time. According to this is the simple component of time series. So in my next lecture, I will discuss about the next model, next algorithm of DA. So this time, thank you.